The electrical installation described does not comply with the National Electrical Code, or NEC, and is considered unsafe. The lack of a ground conductor in the electrical metallic tubing, also known as EMT, is a significant concern. The electrical metallic tubing should have a ground conductor installed inside it to provide a continuous electrical path to ground. This conductor is typically a bare copper wire or a green striped conductor. The absence of a ground conductor in the electrical metallic tubing creates a potential safety hazard, as it can lead to shocks or electrical fires if a fault occurs. The purpose of the ground conductor is to provide a low impedance path for fault current to return to the source, which allows overcurrent protection devices, such as circuit breakers or fuses, to quickly trip and energize the circuit. This helps to prevent electrical shock hazards and minimize the risk of fire. Without a proper ground conductor, fault current may find other paths to ground, such as through a person touching a metallic enclosure, which could result in a dangerous electrical shock. Furthermore, the use of a common white conductor for multiple feeds also violates the National Electrical Code. White conductors are typically used as neutral conductors, and using them as hot conductors, meaning carrying current, can lead to confusion and electrical hazards. Each circuit should have its own dedicated neutral conductor. A neutral conductor is a grounded conductor that carries current from the load back to the source. When multiple circuits share a single neutral conductor, it can become overloaded, which can cause the conductor to overheat and potentially start a fire. It can also create voltage imbalances in the circuits, which can damage equipment. In addition, using a common neutral conductor can make it difficult to troubleshoot electrical problems. If a problem occurs in one circuit, it can be difficult to determine which circuit is causing the problem because the circuits are all sharing the same neutral conductor. The National Electrical Code specifies requirements for grounding and neutral conductors to ensure the safety and proper functioning of electrical systems. These requirements are based on established engineering principles and industry best practices. The National Electrical Code is a widely adopted code that sets the standard for safe electrical installations. The specific National Electrical Code articles that are relevant to the described situation are Article 250, which covers grounding and bonding, and Article 200, which covers the use and identification of grounded conductors. Article 250 provides detailed requirements for grounding electrode systems, equipment grounding conductors, and bonding of metallic enclosures. These requirements are designed to ensure that a low impedance ground fault path is provided, which is essential for the proper operation of overcurrent protection devices and the prevention of electrical shock hazard. Article 200 specifies the requirements for the identification and use of grounded conductors, including the use of white or grey-colored insulation. This article also prohibits the use of grounded conductors for purposes other than serving as a neutral conductor. To correct the electrical installation and ensure safety and compliance with the National Electrical Code, several steps need to be taken. Firstly, a ground conductor must be installed in the electrical metallic tubing. This can be accomplished by pulling a bare copper wire or a green striped conductor through the electrical metallic tubing and connecting it to the grounding electrode system. The size of the ground conductor must be determined based on the size of the circuit conductors, as specified in the National Electrical Code Table 250.122. Secondly, separate neutral conductors must be provided for each circuit. This means that each circuit must have its own dedicated white or grey-colored conductor that is connected to the neutral busbar in the panel board. The size of the neutral conductor must be determined based on the calculated neutral load for each circuit, as specified in the National Electrical Code Article 220. It is important to note that the neutral load may be less than the phase load in some cases, such as when the circuit supplies predominantly nonlinear loads. Thirdly, all electrical connections must be properly made and tightened. Loose connections can create resistance, which can cause the conductors to overheat and potentially start a fire. All connections must be made using approved connectors and terminals that are properly sized for the conductors being used. It is also important to ensure that all connections are clean and free of corrosion. Fourthly, the electrical system must be inspected and tested to verify that it is functioning properly. This includes performing continuity tests to ensure that the ground conductor is properly connected and that there are no open circuits. It also includes performing insulation resistance tests to ensure that the conductors are properly insulated and that there are no ground faults. The electrical installation needs to be corrected to ensure safety and compliance with the National Electrical Code. This includes installing a ground conductor in the electrical metallic tubing and providing separate neutral conductors for each circuit. It is recommended that a qualified electrician inspect and repair the electrical system to bring it up to code. A qualified electrician has the knowledge, skills, and experience necessary to properly assess the electrical system and make the necessary repairs. The electrician will be able to identify any other potential hazards and ensure that the electrical system is safe and compliant with all applicable codes and regulations. When selecting an electrician, it is important to choose one who is licensed and insured. A licensed electrician has met the requirements set by the state or local jurisdiction and has demonstrated competence in electrical work. An insured electrician has liability insurance, which protects you in case of any accidents or damages that may occur during the electrical work. It is also a good idea to ask the electrician for references and to check their online reviews. This will give you an idea of the quality of their work and their customer service. In addition to correcting the electrical installation, it is also important to educate yourself about electrical safety. This includes learning about the hazards of electricity and how to prevent electrical accidents. You should also learn how to recognize the signs of an electrical problem and what to do if you encounter one. There are many resources available to help you learn about electrical safety, including the National Electrical Code, the Electrical Safety Foundation International, and your local utility company. By taking the time to educate yourself about electrical safety, you can help protect yourself and your family from electrical hazards. The National Electrical Code Section 250.4 addresses grounding requirements. The requirements ensure that electrical systems are grounded in a way that limits voltage to ground and facilitates the operation of overcurrent protection devices. Proper grounding minimizes electrical shock hazards and reduces the risk of fire. Section 250.4 covers general requirements for grounding electrical systems, including the types of grounding systems permitted, the methods of grounding, and the requirements for grounding electrodes. It emphasizes the importance of creating a low-impedance ground fault path to ensure that fault current can quickly and safely return to the source, tripping over current protection devices. The code specifies acceptable grounding methods. This may include using metal raceways, equipment grounding conductors, and bonding jumpers to create a continuous electrical path to ground. The grounding electrode system typically consists of a ground rod, ground plate, or underground metallic water pipe that is connected to the building's electrical system. The National Electrical Code Section 200.4 covers identification of grounded conductors. The section requires that grounded conductors, typically neutral conductors, be identified by a continuous white or grey color. This identification helps to distinguish neutral conductors from ungrounded conductors, reducing the risk of accidental contact or incorrect wiring. The code specifies the acceptable methods for identifying grounded conductors, such as using white or grey colored insulation or marking the conductor with white or grey tape. It also prohibits the use of grounded conductors for purposes other than serving as a neutral conductor, such as using them as hot conductors in a circuit. The proper identification of grounded conductors is essential for electrical safety and helps to prevent electrical shock hazards and equipment damage. Incorrectly identified conductors can lead to confusion and increase the risk of electrical accidents. If the white conductor is used for a hot feed, this is against code. White wires should only be used as the neutral. The exception is in certain cases the white wire can be re-identified with colored tape as something other than neutral to be used as a hot or other feed. The NEC covers this situation. The NEC is updated every 3 years, so it is important to consult the latest edition to ensure compliance. The NEC is a comprehensive set of standards that covers all aspects of electrical installations. It is essential for electricians, electrical contractors, and anyone involved in electrical work to be familiar with the NEC. The NEC is a living document that is constantly evolving to reflect changes in technology and industry best practices. By following the NEC, you can help to ensure the safety and reliability of electrical systems. In conclusion, the electrical installation described in the question is not in compliance with the National Electrical Code and presents a significant safety hazard. The lack of a ground conductor in the electrical metallic tubing and the use of a common white conductor for multiple feeds are both violations of the NEC. To correct these issues, a ground conductor must be installed in the electrical metallic tubing, and separate neutral conductors must be provided for each circuit. It is recommended that a qualified electrician inspect and repair the electrical system to bring it up to code. By taking these steps, you can help to ensure the safety and reliability of the electrical system and protect yourself and others from electrical hazards.